Hello students, this video is a continuation of the classification of chemical reactions. In previous fourth video you have learned that chemical reactions can be broadly classified into three major categories: 1 acid-base reaction, 2 precipitation reaction, and 3 oxidation and reduction reaction. In the previous fourth video we learned that acid-base reaction is a reaction that involves transfer of proton, and precipitation reaction is a reaction that produces an insoluble ionic compound. In this fifth video I will explain you details of the oxidation and reduction reaction. Oxidation and reduction reaction is a type of chemical reaction that involves transfer of electrons, and I am going to explain you 5 details of oxidation and reduction reaction. 1. Definition of oxidation and reduction reaction. 2. Definition and assigning oxidation number. 3. Writing half reactions for redox process. 4. Identifying and defining oxidizing agent and reducing agent. 5. I will explain you subclass of redox reaction. Finally, we will have some activities to be done by yourself. And let me move to the definition of oxidation and reduction reaction. The definition of oxidation reaction is different in different cases. That is one in the earlier definition. The earlier definition is oxidation is defined as it is a chemical reaction that involves the loss or removal of hydrogen, and reduction is a chemical reaction that involves the loss or removal of oxygen. Example: if you see this chemical reaction involves the removal of oxygen, so it is considered as the reduction, whereas this chemical reaction is oxidation because it involves the removal of hydrogen. This is one definition. Another definition is oxidation is a chemical reaction that involves the addition or gain of oxygen, and reduction is a chemical reaction that involves the addition or gain of hydrogen. Example: if you see this chemical reaction involves the addition of hydrogen, so it is considered as reduction. And if you see this chemical reaction involves the addition of oxygen, so it is considered as the oxidation. Similarly, if you take this chemical reaction involves the addition of oxygen, and it is considered as the oxidation reaction. This is the definition of oxidation and reduction in terms of loss or gain of or addition of hydrogen and oxygen. And the current definition is based on the addition and the gain of the electrons. Oxidation is a chemical reaction that involves loss of electron, whereas reduction is a chemical reaction that involves gaining of electron. Or oxidation is a reaction in which its oxidation number increase, and reduction is a chemical reaction in which its oxidation number decrease. To memorize oxidation, you can use oil. Oil stands for oxidation is loss of electron, and you can use Rig. Rig stands for reduction is gain of electron. Example, if you consider this chemical reaction, is this chemical reaction oxidation half reaction or reduction half reaction? It is oxidation half reaction because its oxidation number increases from 0 to +1. And if you take this chemical reaction can be considered as reduction because its oxidation number decreases from 0 to -1. This is the way of identifying oxidation and reduction reaction. And note that oxidation always involves the loss of electrons and may involve the addition of oxygen and loss of hydrogen, and reduction always involves the gaining of electrons and may involve the loss of oxygen and gain of hydrogen. This is the definition of oxidation and reduction reaction. What is oxidation number? Oxidation number is the number of electrons that an atom appears to have gained or lost when it is combined with other atoms. Its value can be integers including 0 and fractional numbers, and there are some rules to assign the oxidation number. And the first rule is rule 1 for uncombined elements. The uncombined elements has 0 oxidation number. For example, sodium, magnesium in the uncombined form has 0 oxidation number. Rule 2 is oxidation number for monoatomic ion. The oxidation number for monoatomic ion equals the charge on the ion. Sodium has +1 charge, so its oxidation number is +1. Magnesium has +2 charge, so its oxidation number is +2. Sulfur has -2 charge, its oxidation number is -2. Rule 3 is the oxidation number for oxygen. The oxidation number of oxygen in a compound is usually -2 except in 1-peroxide. In peroxide, the oxidation number of oxygen is -1. Example, if you calculate the oxidation number of oxygen in this compound, it becomes -1. 2. The oxidation number of oxygen in superoxide is minus 1 over 2. If you calculate similarly the oxidation number of oxygen in this compound, it will become minus 1 over 2. The oxidation number of oxygen in oxygen difluoride is plus 2. Similarly, if you calculate the oxidation number of oxygen in this, it will become plus 2. This is the oxidation number of oxygen. The rule 4 is the oxidation number for hydrogen. The oxidation number for hydrogen is minus 1 when combined with metal. Example, in this case, means sodium hydride, calcium hydride, ammonium hydride. The oxidation number of hydrogen becomes minus 1 because it reacts with a metal. Then the oxidation number of hydrogen when reacted with non-metal will be plus 1. Rule 5 is the summation of oxidation number of all elements. The summation of the oxidation number of all elements in one neutral atom is equals to 0. Example, if you sum up the oxidation number of hydrogen, sulfur, and oxygen in this neutral compound, it will become 0. 2. The sum of the oxidation number of all atoms in a molecule or a polyatomic ion equals to the charge on the molecule or the ion. Example, if you sum up the oxidation number of sulfur and oxygen, the summation of this oxidation number equals to the minus 2. That is the charge of the polyatomic ion. Rule 6 is the oxidation number of elements in a group. Group 1 has plus 1 oxidation number and group 2 has plus 2 oxidation number. This is the rules for assigning oxidation number. Example, assign the oxidation number of nitrogen, chromium, manganese, and phosphorus. And the answer will be, for nitrogen, let the number of nitrogen will be X. By the way, you can write this nitric acid as hydrogen plus nitrate in ionic form. So you can simply calculate the oxidation number of nitrogen in the nitrate form. So let its oxidation number will be X, and the oxidation number of oxygen is obviously minus 2. So 1 nitrogen times X is X. 3 oxygen times minus 2 is minus 6, equals to its charge, that is the charge on the ion. So after calculating, the oxidation number of the nitrogen becomes plus 5. Similarly, for chromium, let the oxidation number of chromium will be a Y, and 2 times Y, 2Y, and oxidation number for oxygen is minus 2, that is 7 times minus 2, that is minus 14, should equal to the charge of the polyatomic ion, that is minus 2. After calculating, Y becomes the plus 6, so oxidation number for chromium is plus 6. And for manganese, let the oxidation number of manganese is X, and X, that is X, 1 times X, and the oxidation number for oxygen is minus 2. 4 times minus 2 is minus 8. It will become minus 1 of the polyatomic ion. And finally, you'll get X will be plus 7. So the oxidation number for manganese is plus 7. And the oxidation number for phosphorus is similar. In the similar calculation, it will become the plus 5. This is assigning and identifying the oxidation number. Another thing is writing half reaction for redox reaction. Oxidation in reduction reaction occurs simultaneously or cannot occur independently, and redox reaction involves the transfer of electrons, except in reaction in the covalent compound. For example, if you see this chemical reaction of covalent compound, there is no lose or gain or transfer of electron. Instead, the bonding is, or the reaction is formed by sharing of electron. But even though there is no transfer of electron, but there is change in oxidation number. So this is one exception. Another thing is identifying the oxidation in reduction reaction. Identify the oxidation in reduction reaction for this chemical reaction. Is this chemical reaction oxidation or reduction reaction? To identify whether this is oxidation or reduction reaction, observe the oxidation number of the reactants in the product. Oxidation number for magnesium is +2, and in the product side is 0, so its oxidation number decrease, so it is a reduction. In this case, the oxidation number of iron from 0 to +3 increase here, so it is oxidation. Example 2. Identify and write the half reaction for this chemical reaction. 1. Oxidation reaction. Oxidation reaction is a reaction from zinc to zinc 2 plus, that is zinc to zinc 2 plus. This is there is increase in oxidation number from 0 to +2, and reduction one is from copper to +2 copper, because there is a decrease in the oxidation number. Similarly, for example 3, identify or write half reactions for this chemical reaction. The answer will be, and there is an increase in oxidation number from iron 2 plus to iron 3 plus, so this is oxidation half reaction, and the reduction half reaction becomes this one. If you calculate the oxidation number of chromium in this compound, it becomes +6, and in the product side there is +3, so oxidation number decreased from +6 to +3. This is a reduction half reaction. This is one of the writing half reaction for redox reaction. Another thing is defining and identifying oxidizing and reducing agent. Oxidizing and reducing agent. What is oxidizing and reducing agent? Oxidizing agent is a substance that gains an electron and causes the oxidation, and it undergoes reduction, or the species that is reduced, and its oxidation number is decreased or become more negative. A reducing agent is a substance that gives up an electron and causes a reduction, and its oxidation number increased or becomes more positive, and it is a species that is oxidized or undergoes the oxidation. Example, identify the substance as an oxidized or reducing agent or reduced or oxidizing agent in the following examples. 1. From this chemical reaction. From this chemical reaction, it is clear that zinc is oxidized from zinc 0 to zinc 2 plus, so this is oxidation reaction, and zinc involves the oxidation reaction, so zinc is considered as the reducing agent because it is oxidized. Similarly, copper is reduced from copper 2 plus to copper 0, and copper 2 plus is act as the oxidizing agent. Note that always oxidizing agent and reducing agent appears in the reactant side, not in the product side. Another example is this one. Identify oxidizing agent or oxidized reduced and reducing agent or oxidized species, and for this case iron is oxidized from 0 to +2. This is oxidation reaction, and iron is oxidized, so iron is the reducing agent. Similarly, copper from copper 2 plus to copper 0 is reduced, so copper 2 plus is oxidizing agent. Another example is this one. Identify the oxidizing agent and the reducing agent for this chemical reaction, and the answer will be magnesium is oxidized, so it is act as the reducing agent, and hydrogen is reduced, it acts as the oxidizing agent. Chlorine in this case is a spectator ion, it has no role in it, is not produced in the, it acts as the simply for facilitating the chemical reactions. This is identifying the oxidizing and reducing agent. Another is the subclass of redox reaction. There are two classes of redox reaction. One is a combination reaction. This is the reaction in which the reaction that involves the combination with the oxygen. Oxygen is used as the oxidant or oxidizing agent. Another is single displacement or replacement reaction. In this case, the single replacement or displacement case is let me explain more details on the combination reaction. Combination reaction, as I have told you, that combination reaction is a reaction that interacts with oxygen and produces heat, often in the form of light, in the form of flame. Generally, any substance that reacts with oxygen is considered as a combination reaction. Example, you can take these all examples. These all examples are examples of the combination reaction because the substance is reacted with oxygen, and the single displacement and replacement reaction is a reaction in which an ion in a solution is displaced or replaced via the oxidation of the metal. Example, the reaction with zinc reaction with hydrochloric acid, and zinc displaces the hydrogen. Copper reacts with the silver nitrate. Copper displaces or replaces the silver. So this is the examples of the redox reaction, subclasses of the redox reaction. Another is the activity. You are expected to do the following activities. Assign the oxidation number for the underlying elements. In this case, one activity. The second activity is identify the reactions as oxidation in reduction reaction. Do this by yourself, and again identify the substance as oxidizing agent and reducing agent, whether this chemical reaction is oxidation half reaction or reduction half reaction. This is all about today's lesson. The coming video will be balancing redox reaction. See you next time. Bye bye.